Today we're looking at Note 7.2, Transformations of Exponential Functions. So today we're going to be working with the exponential parent function base 2. And this is because, if you recall, when you work with larger bases like base 10, the graph grows very quickly, so the points don't tend to fit on the graph, especially if you shift it. So base 2 is a nice base to work with because the points are so much smaller that generally, no matter how you shift the graph, all the points will still fit. So what I want you to understand, though, is while we're working with base 2, the transformations still act the same way if the base were 3, 4, 5, 6, 7, so on and so forth. So what we're going to be doing today is graphing each function. We're going to be sure to label that asymptote, and we're going to think about the effect of the transformation on the domain, range, x and y intercept, and the asymptote. So to begin to graph our parent function, base 2, we have the point -1, 1/2, 0, 1, 1, 2, and 2, 4. Recall that this graph will go all the way left, all the way right forever. It will get really, really close to the x-axis, but never ever touch it. It'll just hug it. Okay? So I'm going to try to darkly draw my asymptote so you can see I do have an asymptote on the x-axis. All right, so reminder, the domain for this graph goes all the way left, all the way right. So all real numbers. Elements of all real numbers, negative infinity, positive infinity. The range, however, is restricted. It's y such that y is only greater than 0. So parentheses 0, comma, infinity. Okay, that's my domain and range. My x-intercept is not applicable. You should know why. There's an asymptote on the x-axis. Can't have an x-intercept if there's an asymptote on the x-axis. Okay, my y-intercept for this graph is 0, 1. And last but not least, my asymptote is on the line y equals 0. Okay. So looking at the transformations, as you might imagine, the -5, as it has in the past, out here on the end, moves the graph down 5. Okay, so the first thing I'm going to do is I'm going to go down 1, 2, 3, 4, 5, and I'm going to plot my new origin. Y'all, I cannot emphasize enough, when you plot that new origin right away, where your new x-axis would be, draw that asymptote right away, because if you forget it, that's unnecessary points off. Okay, there's my asymptote. Here's my new origin. From my new origin, I'm going to plot my original points. -1, 1/2, 0, 1, 1, 2, 2, 4. I'm going to draw my graph hugging the asymptote, arrows on both ends. So again, my domain x such that x is an element of all reals, negative infinity, positive infinity. Now my range has shifted down, so y such that y is greater than -5, that's my new asymptote. So -5, comma, infinity. Okay, my x-intercept, my x-intercept, I'm so sorry, is where my y value is 0. Y'all, I haven't taught you how to solve exponential equations yet. Don't worry, it's coming. So for now, if the x-intercept isn't a whole number, I don't want you to include it. There is one, so I definitely don't want you to put in a because that would be false. There is one, it's just that we don't know exactly what it is yet. So for now, leave it blank. My y-intercept, on the other hand, is 0, 1, 2, 3, 4. 0, -4. Okay, and my asymptote is y equals -5. Okay, so moving right along, the +4 in the exponent, isn't that neato? So a plus or minus in the exponent, as it did with square root, in the square root, as it did with quadratic, in the parentheses, anything in the whatever based on the parent function, in this case in the exponent, is your horizontal movement. So that +4 shifts my graph left 4. So as I go left 1, 2, 3, 4, there's my new origin. Isn't this interesting? When I go left and right, is my asymptote going to change? Hopefully at home you're screaming, well, no, Miss Garcia, it's not. Okay, my asymptote stays the same. Still draw it, okay? Don't want you to get unnecessarily points off. So plotting my original points from my new origin, left 1 up a half, left none, left or right none up 1, then 1, 2, then 2, 4. So drawing my graph here, making sure I can see arrows on both ends. All right, there's my graph. So my domain, as you might have guessed, and hopefully you're kind of getting sick of, because we're going to talk about it at the end, is all real numbers. Okay, goes left and right forever. My range, still the same as the parent function. Okay, my x-intercept, in this case, again, I can put NA because my asymptote is on the x-axis, so not applicable. My y-intercept, you can find. Although it's not on the graph, you could do one of two things. You know every single time this number is doubling, so from this point to this point I go 1, so from this point to this point I go 2, so from this point to this point I'd go 1, 2, 3, 4. From this point to this point I'd go 8. You could think about it that way, or the y-intercept is always where x is 0. Plug in 0 for x. So 2 to the 0 plus 4 power. Well, what's 0 plus 4? It's 4. So it's 2 to the 4th. It's 16. So the y-intercept is going to be 16. You can figure that out. Okay, the asymptote is still y equals 0. All right, moving right along. So we have y equals 2 times 2 to the x. We sort of touched on this earlier in that we talked about a values. So this is an a value of 2. So remember, an a value of 2 would be a vertical stretch by 2. If this a value were 1/2 or 1/3, something less than 1, but bigger than 0, that would be a vertical shrink or compress. But in this case, we have a stretch. So that means I need to come off to the side. I need to take my original, sorry, I can't talk and think sometimes. I need to take my original x and y values and multiply my y values by 2. So 2 times 1/2 is 1. 2 times 1 is 2, 2 times 2 is 4, 2 times 4 is 8. Okay, my origin did not change, so my asymptote stays the same. So I'm going to go ahead and shade that in as darkly as I can to be sure that my teacher can see it. Wink, wink. Okay, plot my new points. -1, 1. 0, 2. 1, 4. 2. 1, 2, 3, 4, 8. Okay, so just growing at a faster rate. Okay, but arrows on both ends need to see. All right, so domain, x such that x is an element of the reals. Okay, my asymptote didn't change. Isn't that interesting? The stretch doesn't change the asymptote, so the range stays the same as the parent function. Okay, x-intercept, again, not applicable because there's an asymptote there. I'm going to kind of draw a squiggly here so I can... Okay, my y-intercept is clearly visible on the graph, 0, 2. And my asymptote, again, still y equals 0. Okay, moving right along. Last one to talk about transformation. So a negative out in front. Y'all know a negative out in front makes me reflect over x, specifically x. All right, so off to the side here, I've got plenty of room. Hopefully my hole punch won't punch through this. X, y, -1, 1/2. What am I doing? 0, 1, 1, 2, 2, 4. Multiply the y values by -1, so -1/2, -1, -2, -4. Cross those out. So again, I don't shift any, so my asymptote stays the same. Okay, asymptote stays the same. So my coordinate, my first coordinate though, is left 1, down 1/2, 0, -1, 1, -2, 2, 4. So I personally kind of have to flip my page to draw this, but there you go. There's my graph. So interestingly enough, even after the reflection, my domain is still, this graph still goes all the way left, all the way right, forever. So it's still all real numbers. My range has changed a little in that I still have this boundary at 0, but the graph, instead of going up, goes down. So y such that y is less than 0, so negative infinity to 0. Okay, my x-intercept is still non-existent because of the asymptote. My y-intercept is now at 0, negative 1, and my asymptote still at y equals 0. Okay, last one, let's combine. All right, so this graph goes right 1, up 3, right 1, up 3. So that's the first thing I'm going to do. Right 1, up 1, 2, 3. I'm going to draw that new origin, which means I need to go ahead and just take the time to right now draw that asymptote. Okay, I also reflect over x. So in order to save time, I've already got the table for reflect over x. I'm just going to utilize it. I'm not going to redo. I'm not going to reinvent the wheel. So from here, I'm going to plot negative 1, negative 1/2, 0, negative 1, 1, negative 2, and 2, negative 4. So there's my graph, and as you have already probably gotten the good idea that my domain is still all real numbers, my range for this graph is y such that y is less than 3, so negative infinity, comma 3. My x-intercept is not a whole number value, so just don't worry about writing it for now. My y-intercept, while it's not a whole number value, there's no guessing involved. I know exactly what point this is. It's 0, comma, that was down 1/2, so this is up 2 1/2, so it's 2.5, but y'all know preferably I prefer 5/2. Okay, and then so x-intercept, y-intercept, asymptote, last thing. Asymptote is now at y equals 3.